Good morning, good afternoon, welcome. I'm very pleased to be joined by Bianca Grabner. Bianca is a project manager at HyCentA Research, working in the critical area of electrolysis research. Is going to be giving her and one of her colleagues is going to be giving one of the master classes at the World Electrolysis Congress. So delighted to be able to have a chat with you today, Bianca, and get your views around this important link in the value chain. So welcome, Bianca.
Thanks for having me. Pleasure
Yeah,
to be here.
cheers. So, I mean, electrolysis is obviously a huge area of research. Obviously, I think most electrolysis presentations start off by saying we've been doing electrolysis for hundreds of years, but maybe to maybe unpick that statement that there's obviously yes been electrolysis for hundreds of years, but there's huge amounts of research and work going on into lots of different electrolysis pathways and platforms that have different benefits, etc. You're working on a few of those. So maybe you can give us your sort of big picture overview of electrolysis and then maybe dive into some of the work that you're doing. And we can have a look at where it is on the technology readiness level, etc.
Mhm. Thank you. Of course, we've been doing electrolysis for hundreds of years, but back then the efficiency might not have been the the challenge. Um, the old technology is AEL, so the alkaline technology, but we are looking into more sophisticated technologies. PEM is already almost on the same TRL as alkaline electrolysis and commercially available. However, there are technologies that are sometimes more efficient, with a higher degree of efficiency, more suitable for specific applications, or in some cases, just more environmental friendly. And these are the technologies that need to develop to actually provide the right technology for all applications and also to scale up the electrolysis to a scale where we need it in 2030 and 2050.
Yeah. And when you say less environmental impacts, what are you referring to specifically?
I'm referring specifically to critical raw materials. Um, we are all aware of the iridium and platinum demand for the PEM electrolysis, and we are aware that the iridium supply does not match with the demand that we need to actually roll out PEM electrolysis to the multi-terawatt scale that we would need in 20 or 40 years. And
Yeah.
therefore, I think there's a nice alternative, the alkaline exchange membrane technology, so the AEM electrolysis,
Yeah.
which can operate completely critical raw material free.
Mhm.
However, this is definitely on a lower tier L level so far, and therefore our research is focusing on developing this technology towards the TRL that PEM offers already today.
Yeah, yeah. And in terms of some of the different pathways that are suitable for different applications, maybe you could sort of help us unpick that for people that aren't familiar.
Sure. Um, well, the membrane technologies are very compact in their design and therefore they are very dynamic. So for all direct coupling of renewable energy sources to electrolysis, this might be the go-to solution. Um, for example, SOEC with high temperature applications might be the go-to solution for industrial application where we already have uh, heat, waste heat
Yeah.
that we can use to heat the electrolyzer. And this technology also offers a very, very high efficiency.
Mhm.
So this might be the right one here.
Yeah. Yeah, the SOEC is obviously the solid oxides for people not familiar. So
Mm.
yeah, so they could integrate into industrial heat applications. And in terms of the masterclass that you're going to be running at the World Electrolysis Congress, can you talk a little bit about what you're going to be covering?
We are going to be covering the whole development process that is necessary to actually get electrolyzers ready for the market entrance. So we're taking a look at different development stages from the single cell to the stack development, but also to system development, and where the main challenges are today.
And is that more around the manufacturing process to produce electrolysis units?
It's both. It's for the research and development that's going on, but we always have to keep in mind that the products need to be manufactured. So we also already incorporate that in our development process, and therefore the manufacturing of each component up to the system will be discussed.
Yeah, and we probably didn't talk really about in introducing HyCentA. Maybe you could give us a background to the organization and the services that you provide and the work that you're doing for the industry.
Sure. HyCentA has experience of 18 years with hydrogen technologies, and we are covering the whole economic value chain, starting from production, storage, distribution, and utilization. And we are focusing on the research and development of these hydrogen technologies.
Yeah.
We are divided in 4 areas. Myself, I'm a project manager and deputy area manager of the electrochemicals technologies department, where we are focusing on all sustainable technologies for hydrogen production. So first and foremost, electrolysis technologies, but also novel technologies such as photoelectrochemical processes and also synthesis of chemicals, so electrochemical synthesis. We offer a lot of services in testing and research. So we have a more than 1,000 square meter research facility where we can cover research and development of single cell components, single cell testing, stack testing up to 150 kilowatts. And this year, we will commission a electrolyzer system test field, which is open to all electrolyzer technologies for low temperature and high temperature, where we can test systems up to 1.6 megawatt.
Right, excellent.
A straightforward opportunity for industrial partners where we can actually accompany them a little bit further into the market entrance. So we can actually cover the whole value chain of component to final system.
Yeah. And how many people work in the organization in HyCentA?
Excuse me? Sorry.
How many people work in the organization?
We have 90 researchers, which are almost equally distributed on the 4 areas. So apart from the electrochemical technologies area, we have one focusing on infrastructure technologies and industrial applications of hydrogen, one that is focusing on mobile applications, so fuel cell system development. Sorry. The 4th area is on measurement technologies and circularity.
Yeah, excellent. Well, excellent. Well, as many thanks. It was great to chat to you, and we look forward to the work that you're doing and helping you, elevate the technologies up the technology readiness scale, and indeed looking forward to the masterclass, I think on the 4th of March in Düsseldorf. So many thanks, Bianca.
Thank you. I'm very much looking forward to the event.
Excellent. Take care now. Bye bye.
Thank you. Bye bye.